Hello everyone, let's solve this LeetCode problem number 200, numbers of island. Okay, for this problem, give an m by n 2D binary grid, so which represent a map of ones or zero. Zero means water, ones means land, and then we return the numbers of islands. Okay, so what was the definition of islands? So an island is surrounded by water, is by zero. Okay, and is formed by connected adjacent lines horizontally or vertically. So you may assume all four edges of the grid are all surrounded by water. Okay, so here's the example. We can see this grid. So if we start from this one, and then all the neighbors, if it's ones, then we connect it together. So for this case, the outline should be like this, this. Start from here, 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 here. Okay, because it's only one connection. With this one, so the result is 1. So this is another example. So we can see here is an island. Okay, so one, this part, this two, this one, and also this one is another island, and this two is an island. So the result is will be 3. Okay, so how do we solve this problem? Let's use this example. In this video, I'm going to use the BFS. Okay, so using the BFS, we are going to use a queue, the data structure. The queue is first in, first out. So how do we do? So we can start from iterating from row by row and then column. Okay, so first let's iterating this one. So for the grid 0, 0, okay, we will check if this one is equals to 0, it's not water, right? Or if it's not visited before, so we update our answer. So the answer initially is 0, but now we updated 1 because we found 1 right here. And then what we do, we start to do the BFS. So BFS, how to do it? BFS, we create a queue and then we mark this visited. So this one, if visited, we mark it as true. And then we offer this 0, 0 to the queue. We offer this one. To the queue. Okay, after we offer it, we will have a while loop. We will check if the queue is if the queue is empty or not. So the queue size now is greater than 0. The size here is 1. Okay, the size here is 1. Sorry about that. Here is 0. Here is 0. Okay, and then what we do, we will start first. We will pull this current out. So what we do, we pull this out, and then we will do 4 direction search. Okay, we will check the 4 direction if anything is 1 or visited or 0. So it depends on the situation. We will run the code. So for this problem, for this grade 0, 0. So first let's run, let's say the down. Okay, the down direction. And then we met a 1. So what we do here? So after we met the 1, so we just put this one as a visited, and then we offer that one to the queue. So is 0? No, it's 1, 0, because the row number is 1, the column number is 0. Okay, and then we will check the up the up direction. So the up direction is out of boundary, and then we will check the right direction. The right direction, we can see we got a new, this one is 1, so we never visited before, and this number also is not a 0. So what we do, we mark this as a true, as visited, and then we put this one in our queue. We offer this one in our queue. And then we will check the left direction. The left direction is out of boundary, so we just return. No, we just continue. So we iterate all the 4 direction for the 0, 0, the one we just pulled out. So down, down, up, right, left. Of course, you can do other screens, right? You don't have to by order this one, but for me, in this example, I was doing down, up, right, and left. Okay, and then after we finish doing this, what we do now, we will check if the Q is 0 or not. So in this case, Q is not 0. We have 2 elements here. So we will update the size. So this one we just pull out, and the size now is 2, right? And then we will pull this out. We will pull this out. Is 1, 0. We pull this out, and then we will check the 4 directions from this one, the neighbors. Okay, so when we go down is equals to 0, we just continue, and go up is already visit, we continue, and then when we go the right direction is 1. It's not equals to 0, it's never visited. So what we do here, we just mark this visited as true, and then we offer it to our queue. So in this case, this item actually is 1, 1. Okay, and then what we do then, we will check the left side. The left side is out of boundary, so we just continue. So we checked the 4 direction of this one. Okay, and then we checked everything, and then what we do, we pull again. Because the size is 2, we just pulled 1, so we pull again. Pull this one. This one is 0, 1. 0, 1 is here. Okay, so and then we start check the 4 direction of it. So this one is true. So we just continue. So up is out boundary. We continue. The right one is 0. We continue. The left one is true, like it's visited. We continue. So and then we checked all this. So and then after we checked all this, so what we do then, we will check the queue is empty or not. So if the size is greater than 0, in this case, yes, it's greater than 0. So what we do now, the size here is gonna be 1. This is another layer. Okay, so the size here is just 1. So we only have 1. So we pull this out. Okay, this is 1, 1. And then we will check the 4 directions for this cell, right? The down is 0. We just continue. Up is true. We just continue. The right part is 0. We continue. The left part is true. We continue. Okay, so we did all this. And then we will check. And then we will check the queue is empty or not. Okay, so in this case, it's empty. That means this part is an island. Okay, our islands. Okay, so our DFS is ended in this case, and then we will go back. You remember we started from here. We iterate all the cell in this one. So this is the one start from here, and then we will start from here to iterate again. So what do we do? Because this one actually is visited, so we continue. And this one is 0, we continue. This one is 0, we continue. 0, we continue. And visited, continue. Visited, continue. 0, continue. 0, continue. 0, continue. Continue. And then we met the 1. Oh, this one is not equals to 0. It's never visited. So what we do here? So, and then what we do, we will update our answer to 2, and then we will start the DFS again. Okay, we will start the DFS again. So how do we do? So first we we mark this one as visited, and then we offer it in our queue. We offer it in our queue is 2, 2. Okay? Yeah, it's 2, 2, right? And then after we offer it to here, we will check the size of the queue is 1. Okay? The size here is just 1. We updated here. We just pulled this one. So the size here is just 1. And then we start for direction, start from here. So we check the down direction is 0. We just return. The up direction is 0. We return. The right direction is 0. We return. The left direction is 0. We return. Okay. So after we return, so after we return, this round of DFS. This round of BFS is ended, and then we will continually iterating our cells, okay, for this grade. So because we start from here, and then now what we do, we check this one is 0, we continue, 0 is continue, 0 is continue, 0 is continue, this one is continue. And then we met 1 again. This one is not, this cell is not equals to 0. It's also never visit. So first, what we do? So we update our answer to 3. And then we do the BFS. So when we do the BFS, so the first step we do, we make this one as a true and offer this one to the queue. So this actually the 3, 3. Okay, and then what we do, we will check. Oh, this one we just pulled it out. So and then we will check if our queue is 0. Is the size is greater than 0? Yes, it is greater than 0, and the size here is 1. Okay, the size here is 1. Okay, the size here is 1. So what we do now, and then we do the for direction of the for direction and check the neighbors. Okay, the down direction is out of boundary. The up direction is 0, and the right direction is 1. So what we do after we met 1, we put this one is true. We update we offer it in our queue. So this one, it will be 3, 4. Okay, and then we check after we check the right direction. No, this one. Okay, the right direction is T. The left direction is 0. We just continue. So and then we will check the. Now we just pull this out. We are talking about this, and then we will check the queue. It's not empty, and then what we do here. So what we do here, we just kind of like check this for direction for this one. We pull this out, and then we will check the down is out of boundary. The up direction is 0, so we continue, and the right direction is out of boundary. We continue. The left direction is visited, and then we just continue. So we iterate every single cell in this grid, and then we got the answer 3. We just return the 3. Okay, this is basically the algorithm. So for the time complexity for this problem, the time complexity for this problem actually is O M-N. Okay, and then our space complexity is also O-M-N. Okay, let's start coding. So first, what we do here, first we need to actually clarify the for direction. We call it the data. So this is new, and this one. Okay, let's define the for direction. Okay, first we will check the corner case. We will check if grade the length, this is a row, if equals to 0, or the grade, the column for this, the column for this grade, if equals to 0. Okay, in this case, what we do, we just return 0. That means we got an empty grade. Okay, so we don't have any element here, so it's 0. And then we will get the row and the columns of the grade, the length of it. So what we do, we define m equals to grade the length, and then we do n grade here is 0 in the column. Okay, this one. Okay, after we got this one, we will define a visit matrix. Okay, this one, the type are gonna be boolean, is true or false. Okay, this is what we do. New boolean. Here we use m. Here's n. This 2D grade. Okay, yeah, this is one. And then we will define the answer. We initialize. We initial this answer equals to 0. At the beginning, our s line is 0. So we initial this one. We count the element, and then what we do, we iterate every single cell. Okay, start from I equals to 0, I smaller than m, and I plus plus. And then what we do, we for loop the integer j equals to 0, j smaller than n, j plus plus. And then what we do here, we will check if this grade equals to 0, I j equals to 0, or we will check if it's visited or not. Okay, so if we check the grade is not equal to 0 and it's already visited, it's never visited, so what we do, we update our answer, and then we do BFS. Okay, we do BFS. We can put a grade here, I, J, and if it's visited, the visited Boolean 2D matrix. Okay, and then in the final step, we just return the answer. Okay, but how do we do the BFS? Let's do this. Okay, the BFS. This is another one. So what we do, BFS, so the input is char array. Here, right? Is grade, int I, int j, and our visited 2D array actually is a Boolean type. Okay, so here, visited, and what we do first, because we are using data structure of Q, so we will define the Q. Okay, and then this visited, we mark this ij as true because we just visited, right? This is true. After we mark this one is true, what we do, we offer this this one to the queue. We offer it to the queue. The offer and new int ij. And then we will do while loop. Q size greater than 0. Int size equals to Q dot size. And then we do for loop. So how do we do the for loop? We will declare count. Count equals to 0. Count smaller than the size. Smaller than the size. No, the size we just defined. Okay, just 1 second. And the count plus plus. And then we pull this out. We pull the one from the queue. Not pull, yeah, pull. Okay, and then we will check the 4 directions of the current cell. Okay, so for int d means the directions 0, and the d smaller than 4, and the d plus plus. And then what we do here, we initial ni equals to cur. This one is 0. And then we will do delta. Delta here is d. This is 0. And then ng equals to cur. This is 1. And the plus delta. Okay, this one is d. This one is 1. Okay, after we do what we do, so here we can see this is a cur, right? So we just pull this cur out, and then we will check the cur's neighbor. Okay, so we have 4 directions, right? So this is the 4 directions, right? The up, down, right, left. Okay, and then we will check if the neighbors smaller than 0 and the neighbors greater than the length this is a column. So this line actually we are checking it's not make sure it's not out boundary. Okay, if it's out boundary we just continue, and then we will check if great the neighbor ning, this one if equals to 0, or if the visited the ij equals true. 1 second. Here we don't have this one. This one is here. Okay, if visited, what we do, we continue. And then if this one, if grade is not out of boundary, if the grade equals to 1 or never visited, so what we do, we mark this visited njng and ing to true. And then we will offer it to the queue. This is what we do here. So it's an ing. Okay. Okay, let's run the code. Okay, here has some problem. It's offer, it's not off. It's typo. Cannot load from this one is none. Okay, let's check this one. Int this one equals to here. So what we do here, we actually and this one. Okay, let's check this one. Let's make a check of this one. So here is wrong. Here actually the count is smaller than size. Okay, let's check again. Okay, let's check out here. I think we don't have to check if true. We just do this because our visitor array is already boolean array. And then what we do here, we just run the case. Let's run the code to see what happened. Okay, it's accept. Okay, let's go through the code again. So first we declare the 4 directions. And then what we do here, we do the corner case. We check if this 2D grid is empty. If it's empty, we return 0. And then we get the number of row and columns. Okay, and then we define a visited 2D grid. Okay, the type is boolean, is true or false. So that means we are using the visited array to record this cell if it's being visited or not, and then we count the element. And then what we do, we iterate every single cell. We check if it's not visited. If it's not 0, then we do the BFS. Alright, that means we met element, and then we do BFS. Okay, this is the BFS. So what do we do the BFS? We use the data structure queue, first in, first out. And then first we will make the visited, the one we just found it, and make that one is true. That cell is true. And then we offer that cell to the queue, and we check the queue if greater than 0. We pull the cells, every single cell from the queue, and then we do 4 direction checking. So if it's not this one, to check if it's out boundary, they will continue. This one, if it's equals to 0, is water or is visited, we continue. Only if it's never visited, it's not out boundary, is land, is 1, then we make that neighbor as true, and we offer the neighbor to the queue. Okay, this is basically the algorithm. Okay, let's run the code. It's accept and submit the code. Okay, our algorithm is 36% for faster than the Java Online submission. Thank you for watching. I will see you next time.